This is the test review. I'm gonna skip to number 17. And then we'll come back and get the rest of them. Okay. So this says for the given functions, find f of g of x and g of f of x. So come over here. Gonna do f of g of x. Right? You guys know that you're supposed to list f first. F is 6 over 1 minus 7x, but instead of the x, you're putting a blank there. So 6 over 1 minus 7, instead of x, I'm putting a blank because inside that blank is supposed to go g of x. And g of x is 1 over x. Anybody lost? Okay, so we did that. Now this is not simplified. So the hardest part about this problem is trying to get it simplified. Would there be a problem with this one in the domain? Yes. Okay, because before I even simplify this, I have a fraction down here. Do you guys see that? And this fraction 1 over x is going to give me a problem. So before I even start simplifying, I'm going to go, uh-oh, x cannot be equal to 0. There's not really anything for me to solve there. So I already know that there's going to be a problem in the domain at 0. When I get done with the rest of my problem, I might have some issues somewhere else, but I for sure know that. Okay. The answer, when you get all of this simplified, is 6x over x minus 7. Okay, so that is what's supposed to go in this blank right here, 6x over x minus 7. Do you guys see? So the math behind getting from here to here is a little bit complicated, okay? But there's a pattern here, and it's going to be the same on every one of the tests. So it looks like to me there's still a 6 at the top, but the answer has an x behind it, right? So that's one of the things I'm noticing. I'm noticing that this 1 turned into 1x, and then the minus 7 just got rid of the 1 over x with my answer. Okay, so if we were to work another one, okay, I'm just going to jot this down. Let's say that I ended up getting 5 over 2 minus 3 times 1 over x, because this is what the problem's going to be like. Okay, if I want to go straight to the answer, the 5 should get a what after it? An x. The 2 should get a what after it? An x. And then it's the 1x, 1 over x should just go away, and then we should get minus 3, right? Please don't miss this problem because there's a pattern there. Even if you can't do the math, you should be able to kind of go, that's what I need to put. Okay. So how do we do this? I mean, I would be a bad teacher if I didn't tell you how to do this to get here from here to here without cheating. So we know that if we're going to put the bottom together, we need a common denominator. And so already this is, I'm not going to leave out the step. So this would be 1 minus 7 over x if I multiplied those two together. Then I could say, well, I need a common denominator. I already have a 7 on the bottom, so I can make the 1 be an x over x, because x divided by x is 1. Okay. Kind of come down here. And then I would have 6 is equal to x minus 7 over x. And the way you divide fractions is you multiply by the reciprocal. So I wrote the 6 down as 6 over 1. I changed the division to a multiplication, and I flipped the second fraction. And so that's how you get the answer, 6x over x minus 7. Okay. Am I going to look at the final product here? Are we going to have any other problems? I do, in the domain, I do have an x minus 7. So I can tell you right now that there is another problem, right? X can't be 0. And then also x minus 7 can't be equal to 0. So I would add 7. And so X is not equal to 7. So these two are a problem. Every other number is okay, but 0 and 7. So I'm good from negative infinity to 0. I'm good from 0 to 7, and I'm good from 7 to infinity, but those two are my problems with f of g of x. So D. Okay. The next one asks us to do g of f of x. So the first thing I would do is write down g, and g is 1 over x. So I'm going to write down 1, and I'm going to leave a big blank for x, because inside of there is supposed to go, inside that big blank is supposed to be what f of x is. And f of x is 6 over 1 minus 7x. This one's not that bad. So I'm going to write down 1 over 1 for the number 1. Okay, before we go on, are we going to have any problems in our domain? From the original problem, we've got a fraction in our denominator. So I need to kind of check out, when is 1 minus 7x equal to 0? We subtract 1, so negative 7x is negative 1. Divide by negative 7, so x is 1/7. That one for sure is going to give me a problem. Okay, so I know that. I meant to make that orange, but it didn't take, or I didn't pick it. That was probably it. Okay, so I know I'm having a problem in my domain at x equals 1/7. To finish this one, I wrote 1 over 1, and then I'm going to change my division to a multiplication, and I'm going to flip my second fraction. So that final answer would be 1 minus 7x over 6. Okay, that is a 6. So it looks like I don't have any fractions in the denominator there. So that means that the only problem I have was this 1/7. So the right answer is going to be D. Good from negative infinity to 1/7. I'm good from 1/7 to infinity, but just not 1/7. Any questions about that one? Okay. Let's scroll back up here to number 1. So if I want to graph this problem, how many of you are going to use the intercepts? Anybody? I think we decided that we had nobody that was going to use the intercepts. And I would have used intercepts for this one, but that's okay. Most of you guys told me you would just go ahead and you would solve this for y, and you would go to your graphing calculator, put in the point. So to do that, we would subtract 3x. So 6y is equal to negative 6 minus 3x. Divide every single thing by 6. And so y is equal to negative 1. Negative 3 over 6 would end up being negative 1/2 times x. Okay. On the next one, I will go to the graphing calculator, but on this one, I don't think we need to do that. But we could go to our graphing calculator and plug in this, and then hit our table and look for some values. You just don't want to get any fractions. So I know at 0, the answer is going to be negative 1. At 2, the answer is going to be negative 2. I could get that from the graphing calculator, but so I would go pick the line. I would plot the point 0, negative 1, and 2, negative 2. Connect the dots. Then I'm going to submit that one. Is everybody okay with that one? Okay, so to graph x squared plus 5, it's already solved for y, so it would probably be smart to go to our graphing calculator and type that in. I'm pulling this up on the graphing calculator because on this one, it's important to pick a certain point first to plot. So x squared plus 5. I'm going to look at the graph because if you got, it's been a while since we've done homework on this, but if you'll remember to plot this in the computer, you have to start with this vertex point, right? So it's important that you know what that point is. And then you want to kind of pick something on the left and the right of that. So when we look at our table, we want this 0.05 to be one of our points that we plot, because that's that vertex. So we could pick -1,6 and 1,6, that would be fine. So we had 0,5. Plotted that one first, -1,6 and 1,6. We do want it to kind of look like a U, because the calculator is going to, or the program's going to do this for us. I don't have to really worry about that a lot, but it's supposed to be a U, not a V, right? Questions about that? Okay. So number 3. How do we get this absolute value thing to show up in our calculators? Anybody remember the buttons? It is math. Go over to number, and then you should see where it says A, B, S, and I think parentheses like that. So if we want to type that in, we're going to go y equals math over to number, and it's ABS, and then you hit enter. Okay, because if you forget how to type that in, you might have some difficulties with that. Okay, and the problem was x minus 6. This one makes what shape, guys? Yeah, it makes a V. And so on this one, it is also important to look at your graph and pick out that vertex first, because that's the first point you want to plot. That point looks like it is at 6, 0. So we for sure want to write that one down, 6, 0. And then we could do points on either side of that. So I could pick 5, 1 and 7, 1. Okay. We said we would pick the 0.60 because that was the vertex. And then we could do 5, 1, and we could also do 7, 1. And that makes that V shape for us. Okay. Questions about that one? Determine if something is a function. It always helps me to kind of write this out. -5 goes to 5. 4 goes to 5. Some of you may not need to see this visually. You can probably see it from the chart, but I know that all the X's have to be different. And they are, right? I've got -5, 4, and 7, and they all are different. So this one is a function. So I either need to pick A or D. And to me, the wording here gets me. And I don't know if y'all are like me, but maybe you're not, but the wording is kind of confusing, right? So for sure on your review, you want to pay attention to what we want to pick yes, because each element in the domain corresponds to exactly one element in the range. Okay, so you want to answer your question based on that one. So if it was no, you need to know the opposites of those. Does that make sense? So if it's no, it's not going to be the domain corresponds, right? It's going to be because it doesn't. That makes sense? Okay. I think the easiest way to do this problem is to go to your calculator and go to y equals and type in 5x squared minus 2x and pull up your table and look for 0 and -1 and 2. Okay. I'm not going to go there right now because I think we've done that a million times, but the long way to do that would be to wherever you see an X, you would plug in, on this one, you would plug in a 0. And there's nothing wrong with working this problem the long way. If you did this way, I would definitely check myself using the graphing calculator and look at my table after I plugged it in. But you should be getting 0 and 7 and 16. Okay, questions about that one? So on this one, I would definitely go to y equals 2 minus the absolute value of x and put that in the graphing calculator. It is going to be important that you get that first point so that you can plot where that vertex is. So if we go here, we've got 2 minus the absolute value of x. We could hit graph. So this point right here is going to be important that you know where that one is. All the rest of them don't really matter that much, but you need to know that 0, 2 is on your graph. You could go to your table, or that's probably going to be the first point you want to graph. You could go to the table to fill out the rest of the points. Remember, you can use your arrows to move up and down if your point's not there. So we want to go back and fill in our table. Okay, so on our table, you should be getting, we already found this one, but this one was the important one. You might want to circle that one because when you get ready to plot your points, you'll want to do that one first, whatever your vertex is. Okay, so we don't have to plot all of these, but we have a point at, oh, it was 0, 2, right? Not 2, 0. Let me go back and look at that real quick. So 0, I'm sorry, it's 0, 2 that is the important point. That's your vertex that you want to plot. This point right here, that's our vertex. So 0, 2 is the first point you would want to plot. And from there, it doesn't really matter. We could plot our -1, 1, 1, 1, but we know it makes a V and it goes upside down. It's the absolute value function. Okay, is everybody good with that? I'm sorry. That's the same thing. This is the problem and this is where the answer is. Does that make sense? Yeah. Good question. Okay, so on this one, this is going to be a parabola. It makes a U. It's going to be upside down. So it's going to be important that we find that vertex. So -x squared. Go here. So -x squared plus 8. Okay, and we want to do, we want to go ahead and look at the graph. So this point right here, 0, 1, 2, 3, 4, 5, 6, 7, 8 is going to be the important one. You would go to your table and get the rest of the points from there. Okay. And so 4, 7, 8, 7, 4. We said this point right here is what we want to plot first because it's our vertex. So that point 0, 8. And then from there, it doesn't really matter. So we could do 2, we could do -2, 4, and we could do +2, 4, and that would be good. And this one makes a U, not a V. So you want to kind of curve that off. Okay, questions about that? Number 8, is this a function? Because you use the vertical line test, right? No, it's not a function. Because when you draw a vertical line, it can't touch it more than once. And so this one would actually touch it twice. So this is no, it's not a function. Okay. If it touches it more than once, it's not a function. If you don't know that, you might want to jot that down. Okay, this one also is a little bit challenging for people because they don't understand the notation, but it's not difficult. So I would make sure I wrote down how to work this one. On A, it's asking you, it's saying f of 2. So what it's saying is when x is equal to 2, y is what? So we would go to our graph and we would go to where x equals 2, which is right here, and we'd go up to our function and over, and we would look and see what is y then. Well, the answer is 3. When x is 2, y is 3. Remember that domain goes from left to right. Okay, you're talking about x's here. And so this thing's going to keep getting wider and wider and wider. So there's not going to be any value that's not going to be on there for x because it just keeps going in both directions from left to right. That's why the right answer on this one is all real numbers. Okay, C says any x values for which f of x is 3. What that is asking you is when y is equal to 3, what is x? When y is equal to 3, what is x? Okay, so I go right here, get a different color. So when y is equal to 3 is right here. So actually, we would have, we go on over, we got 2 things going on here. It looks like 2 and 8. So that would be the answers, 2 and 8. Okay, when you're answering questions about the range, you always start, you're talking about y, and you start at the bottom and you go up. Well, down here on my graph, there's not anything here, right? As we go up, we're going to go, okay, it looks like the first time I have anything going on with y would be 0 right here, and it doesn't stop. My graph keeps going up forever. So all the y's that are greater than or equal to 0. Okay, questions about that? Okay, find the domain of the function. So we have a fraction, so you guys know that the denominator can't be equal to 0. So we would solve this problem for 0. So negative 8x is equal to negative 9. Divide by negative 8. So x cannot be 9/8, but it can be everything else. And so the right answer is B. X can be anything but 9/8. Okay. So this one says, here's the problem, find f of -4 divided by g of -4. So this means we would do f of x divided by g of x is where we would start. Tells us over here f of x is -20x plus 3, and g of x is x squared plus 17. At this point, I could type this in my calculator under y equals, and I could look for -4 on my table, and I would get the answer that way. I just want to remind you about that. Or this one's almost as quick just to plug it in. If I want to do f of -4 over g of -4, wherever I see an x, I'm just plugging in -4. And the top gives us 83 and the bottom gives us 33. And that won't reduce. So it's actually 83 over 33. I think a lot of people second guess themselves when they get an answer like that, but sometimes you're going to. Okay. Anybody have questions about that? Okay, this one's saying to do g of x minus f of x. Okay, well, g of x is x squared minus 3, and I want to subtract f of x, which is -3x plus 4. So we want to make sure we distribute that negative to both things over here. So that's going to end up being a positive 3x and then minus 4. And when we combine like terms, we could combine the -3 and the -4 and get a -7. But x squared and x, the 3x, they don't have anything to go with them. So my final answer would be x squared plus 3x minus 7. Okay, and we just talked about how you don't have to write it in this order, but most people do write it in terms of the exponents, highest exponent first, then the next x to the first, and then the whole number at the end. Okay. This problem saying to do f of x minus g of x, and then figure out, well, when x is 3, what's the answer? So f of x is, I'll write this a little bit over here so I have some more of x squared minus 17. G of x is 20 minus x, and I'm supposed to subtract those. At this point, I could plug this in the calculator under y equals just like it is, and I could go to my table and look for when x is 3, what's the answer? Just want to remind you about that. Or I can go ahead and distribute this and say, okay, that's x squared minus 17. This minus goes with both of these, so minus 20 plus x. So these two could go together. That's going to get me x squared plus x minus 37. And then I would plug in a 3. Look at like I said, we could look at our graphing calculator and get the answer too that way. But the right answer is -25. Questions about that? If we add these or subtract them, change here. If we add these or subtract these or multiply these, if it's a product, if it's a problem in one of the domains, it's a problem for both of them, right? Do I have a problem in the domain of f of x? I do, because there's a fraction. And so we know that x minus 1 cannot be equal to 0. So to figure that out, we would add 1 and say, okay, well, we have a problem at 1. That's a problem for f of x. And the domain, it can't be 1. In g of x, there are no problems. There are no fractions there. Okay, so we have no problems in g of x. The only problem we have is 1. And so it doesn't matter if we're adding or subtracting or multiplying, it's going to be a problem in all 3 of them. X cannot be 1. It can be anything else. Okay, so that one looks like it's difficult, but it's pretty, it looks like, oh, that has a lot of parts, but it's pretty easy. It's the same answer for all of these. Okay. If you are dividing, we got a whole new ball game, because when you divide, we can now have fractions. So if we do f of g, if you do f of x over g of x, which is what this is saying, our new function, since here's f of x and g of x, would be 3x minus 4 over 4x minus 8. So we've created a fraction. So now the problem is going to be when 4x minus 8 is equal to 0. So we would add 8. We would get 4x is equal to 8, divide by 4. And so x cannot be, can be anything else, but it cannot be 2, because we've got a problem there now. Okay, questions about that one? This problem's asking you to do f of g I'm gonna go ahead and replace it with an X right now. And then when you get that, it's saying, and then what happens when X is -2? So the first thing you do is write down F, which is 2x plus 1. But instead of the X, we know we're plugging in g of X right there. And g of X is x to the third. So to finish it, you could type this into y equals. You could go look at your table and go, when X is -2, what's the answer? Or you could plug in -2 for X right here. Okay, that's how you would type it in your calculator. When you plug it in when you plug it in for X, you should put it in parentheses because that helps you get the right answer. And it's going to be -15. Okay, questions about that one? Okay. We already wrote 17. Do I need to slow down? Okay. 18. Use the horizontal line test to determine whether this function is 1-to-1. So it's the same as the vertical line test. It can't touch it in more than one time. And this one actually does, no matter where we draw the line. So this function 18 is a no, it's not 1-to-1. Does not pass the horizontal line test. Okay, determine whether this function is 1-to-1. If it is, find its inverse. So what could we do here to determine if this function is 1-to-1? We can graph it, right? See if it passes the vertical line test. So we've got 5 over x plus 7. Five over x plus 7. Is it going to pass the vertical line or the horizontal line test? It passes both, but yeah, because you draw a line and it would only hit it one time if you did a horizontal line. So the answer to that is yes. Okay. So remember to find the inverse. Start out with your function. First thing you do is you turn f of x into y. Second thing you do is you switch your x's and your y's. So now we've got x is equal to 5 over y plus 7. The third thing you do is solve for y. So I think this problem, I like to do cross multiplication on this problem. If you want to solve it another way, that's fine. But I basically just say, I multiply by the things across from each other. So one side would be 5 times 1. The other side would be x times y plus 7. We're trying to get y by itself. That's the goal here. So I've got 5 is equal to xy plus x or 7x if we distribute that x to both things. Okay, we can subtract 7x. And so 5 minus 7x is equal to xy because we're trying to get that y by itself. So finally, we could divide everything by x. So we'd have 5 minus 7x over x. And the right answer is not this, not that. It is 5 over x minus 7. And the way that you get to that is you put that x under each thing. I guess each fraction, you divide it into 2 fractions, and then these x's would cancel out. So you'd be left with 5 over x minus 7. Right? That's the answer they want. They want you to keep going. Don't stop here. Keep going to this answer. Okay. This is a system of equations. We have it lined up x and y and equal sign and our number over here. So that part's good. So we could go to our calculator and type in the matrix and do, this would be 5, 2, 46. 2, 5, 52, and this would be a 2 by 3. Okay. So if you go back and you look at the video on this section, we kind of go step by step how to type it in the calculator. Does anybody in this class need me to show you that? Where you do the RREF and all of that good stuff? If you do, then you definitely can ask me during lab if you need me to slow that down for you. But so we would get the answer would be X is 6 and Y is 8. Okay. Same thing here. We spent a lot of class time really slowing this down. But to type this one, I will go ahead and write what matrix you would type in. So they are lined up for us, X's, Y's, Z's, and the number. So it would be 6, -1, 1, -31, 2, 2, -3, -13, 1, -3, 2, -13. So that's what you type in. You would come up with when you get done on the calculator. Now this is going to change to a 3 by 4 this time. You would get -5, X is -5, 6, and 5. So X is -5, Y is 6, and Z is 5. And like I said, if you need me to slow this down on the calculator and go over this one with you, I would be fine to do that. By eating 1 egg, 1 cupcake, and 1 slice of pizza. So I'm just going to use the letters that we've got. 1 egg, 1 cupcake, 1 slice of pizza. That child's going to have 298 milligrams of cholesterol. If the child eats 3 cupcakes and 4 slices of pizza, that's going to be 85 milligrams. If they eat 3 eggs and 1 cupcake, that's going to be 835 milligrams. So you could absolutely, this is a 3 by 4, 1, 1, 1, 298. 0, because we don't have any eggs on the next row. 3, 4, 85. 3, 1, 0, because we don't have any pizza right here. 835. Okay, are we good with that? So you can do this on the calculator, that RREF. You should get that the egg is 272 milligrams and the cupcake is 19 and the pizza is 7. Okay. Questions about that stuff? 23, graph the inequality. Okay. I'm getting that most of you are deciding you really don't need the inequality sign whenever you're trying to come up with the equation of the line. Okay, so most of you are solving this for Y. So I'm going to do the same thing. I'm going to subtract 3x. So -2y is equal to -8 minus 3x. We would divide everything by -2. So y is equal to 4 plus 3/2 x. Okay, we need some points that we can graph. So if you're following online, go ahead and plug this in your calculator and look at your table and find some points that we can graph and type them in the chat box. But so when I look at this, I'm noticing that 0 would be easy for me to plug in. If I plug in 0 for x, I'm getting 4, but we can also get these from our graphing calculator. If we plug in a 2, that would be 7. So those would be 2 good points. If I plug in 2 for x. So I'm going to say this again. So if you're following along on the graphing calculator or on the Zoom, you need to put some coordinates that we can plot for 23 in the chat box. So I'm going to go ahead and put 0, 4 and 2, 7. Okay. Now we've got to decide if we fill in the line or make it dotted. Which one is it? Fill it in because it has the equal to. So that means we would have a solid line here. And then the last step is to figure out what you shade in. Do you shade in the top or the bottom? And so you remember from last class that we need a test point, and our test point is 0, 0 most of the time, unless 0, 0 is on the line, then we'd have to pick some other point. So I'm plugging in 0. I'm going back to my original equation and I'm plugging in, or inequality, and I'm plugging in 0 for X and Y. So that means 0 is less than or equal to -8. That is false, right? 0 is not less than or equal to -8. Do y'all agree with that? That is false. So that means this point 0, 0 should not be colored in because it does not work. We would color in the part that doesn't have the 0, 0. Yes.
Also, you do use, like, you know how you use the equal sign?
Mm-hmm.
If you do use the equality, like when you divide it by -2, you still flip the sign.
Yes. You are right. You would flip the sign. If you keep the inequality, you flip the sign. Yeah. Is everybody okay? Good question. Okay. There's that one. Graph the linear equality X is less than 3. So you go to your, you want to go to where X is equal to 3. And you put your pencil or your pen or whatever right there. Okay, now we need to draw a line through that, but before we do that, we need to decide, is it solid or dotted? It is dotted because it doesn't have the equal to part. So when we draw our line, we want to pick that it makes this dot a dotted line through there. Some people really like picking this test point. If you do that, 0, 0 would still work. You would say, okay, if X is 0, is that less than 3? So that would be true. So 0, 0 is right here. So you would color in the side that had those points on it, which just makes sense, right? X's that are less than 3 would be all of these on this side. Okay, last problem. Okay, so we've got to talk about two different things. It looks to me like we don't even really have to, I don't know if you guys agree with this, but all of the lines that are drawn are the same. Okay, so I don't really have to worry about drawing the lines, but what I do have to kind of worry about is which line is which line. Does that make sense? Like, I need to know which one of them is Y is greater than or equal to X plus 6. And I need to know which one of them is Y is less than 5 minus X. That's important. So when I look at Y is greater than or equal to X plus 6, this one has the thing in front of it is in front of, we talked about this last class. This is a positive slope. So I know that this line has to be going up. So this line that is going up right here, this is my Y is greater than or equal to X plus 6. And what you might want to do is just kind of draw you it doesn't have to be perfect, but draw you something that's representing what they have. Say, okay, this is my Y is greater than or equal to, because when you start trying to figure this out multiple choice, it starts getting confusing. Okay, so I know that's my, could I, if I really stuck with this, like talking about whether the slope is positive or negative and all that stuff, can I go back to finding some test points and figure out which line it is that way? Or type this in the graphing calculator, figure out some points, but you got to figure out that at least. So then I would go, okay, let's pick a test point. We like 0, 0. So I'm going to say, well, is 0 greater than or equal to 0 plus 6? Is 0 greater than or equal to 6? That is definitely false. 0 is not greater than or equal to 6. And 0, 0 would be right here. So that means I would draw some lines kind of up to say, well, I'd color in the top part because 0, 0 doesn't work. Then I'm going to talk about this other line. So let's make it red. So Y is less than or equal to 5 minus X. Well, I know just from experience that that negative X means that that line is going to be the one that's going down. If I didn't know, I could go to my table and figure out some points to figure out which line it was, okay? Test point 0, 0. Gonna use the same test point, so a 0 less than or equal to 5 minus 0 is 0 less than or equal to 5. Yes, so that's true. I almost put false. Thank goodness you're here. 0 is less than or equal to 5, so that means 0, 0 works. So that means that I would color in the section of this red line that 0, 0 is in. Okay. So this little section right here that has both the red and the purple is the one that works. So that right answer is what? B. Okay, and if you start, some of you are super talented at being able to figure out that. I'll tell you as a teacher, if I don't draw this, I start getting confused. Like, did I say this one was colored in and then that one? And so it helps me to kind of draw it. It takes me a couple extra seconds, but it helps me to get the right answer. Okay, so that is the end of the test review.